Okay, today is the division property of exponents. Our objectives today are be able to find quotient of powers, 2, be able to find positive quotient of powers, 3, be able to find negative quotient of powers. And so you're going to be able to pause this, jot down your objectives if that's what you missed today, and then we'll get into the lesson. So you can pause this. I'm going to be switching out the screens right now. So example 1, is finding quotient of powers. So first we're going to be looking at just numbers. So let's say we have 2 to the 9th power over 2 to the 7th power. Now I could expand this and go 2 times 2 times 2 times 2, yada yada yada, all over 7. But we have a property with the exponent of powers that says, let me expand this a little bit more for you. So let's say I turn this into algebra and I have x, y over x to the z. Okay, we can see that a little bit better. The property of division with exponents states that you take the base, which is x. X is the same. It has to be the same base. Same base is x, so this is my this is my same base, and I can go y minus z. Now what you guys learned the other day is the multiplication property of exponents, where we were adding the exponents together. So my addition and my subtraction, my addition and my multiplication kind of tie in together, whereas my division and my subtraction are going to be able to tie in together. So I want to take the same idea and turn my same base, which would be 2, and then what am I going to do with that 9? It's going to be 9 minus 7. Doing the math, I get 2 to the 2nd power, and then from here I'm just going to evaluate 2 to the 2nd power, which is just 2 times 2, which gives me 4. And so that's going to be my final answer of 4. So let's scroll down a little bit and let's apply this to some more algebra. So let's say I have y all over y to the 4th. Now, if I have an exponent that doesn't quote unquote have, if I have a power that doesn't quote unquote have an exponent, my exponent is always going to be that invisible 1, right? So I have y to the 1st all over y to the 4th. And then I'm going to use that division property, and I'm going to go y1 minus 3, which is going to be y to the negative 2. And a couple of lessons ago, we need to recall that we do not deal with negative exponents. We do not like negative exponents. So if I see a negative exponent, I'm going to bring it back down into the denominator. And so I have y squared in my denominator. What goes up top? I can't just have nothing hanging out here. I'm not going to put a 0 right there. I have a placeholder of 1 right there. So my y to the negative 2 is going to be 1 over y squared. And that's going to be my final answer. So feel free to pause that if you need to, and then we're going to work another one. We have 2 more to work. Okay, now we're going to get a little bit crazier and go m to the fifth into the fourth all over m to the fifth. That quantity is going to be squared times n. Now, a couple things you need to keep track of here. I have this 5 as my exponent going to the base m, this 4 going to n. N has an exponent of what? It doesn't look like anything's there, but again, I want to put a placeholder of 1 in there, and I have m as my base here being raised to the 5th, and now I need to square that quantity. So I want to clean up the top and then clean up the bottom and then use the division property of exponents. So m to the 5th into the 4th, that's already simplified. So I'm going to rewrite it, m to the 5th into the 4th. Now I can start to work with the bottom. Into the 5th, quantity squared, I'm going to multiply the two together, right? 5 times 2 gets me m to the 10th power, and then I keep my n to the 1st. Now that the top and the bottom are simplified, I begin to use the division property of exponents. So I'm going to go m, start to bring things up using the m to the 5th minus 10, and then n to the 4th minus 1. And I could write all over 1, but I don't need to. So what would that be? M to the 5th minus 10 is going to be m to the negative 5. And then this is going to be n to the 3rd. Let me get out of the way there. So, again, I do not like negative exponents. N is raised to the 3rd. He's good to go. I need to get that m out of there. So n to the 3rd stays, and I need to bring that m to the 5th back down. So notice what is happening when I have a negative exponent. If it's already in the numerator, I'm bringing it down to the denominator. If it's in the denominator and it's negative, then I'm bringing it up to the numerator. I'm just going to play this game of back and forth. Whatever's negative, I'm going to flip it up to the numerator. If it's negative in my denominator, I'm going to flip it the opposite way. And so my final answer, because I can't do anything with the rest of these variables, n to the 3rd all over m to the 5th. And that's my final answer for that one. Okay, we got one more crazy one to look at, and then we'll be done with example 1. Okay, so I thought we might benefit from a recap of what I did. So m to the 5th times n to the 4th. Remember, if your variables are right by each other, multiplication is happening. And then in my denominator, I have m to the 5th squared, and then n. And remember, we put a placeholder of 1 in there. Now I go over here. I simplified 5 times 2. That's the multiplication property that we learned a couple days ago. So now I was left with m to the 5th, n to the 4th. In my denominator, m to the 10th, n to the 1st. Since I'm done. I've simplified the numerator, I've simplified the denominator. Now I want to start to use that division property of exponents. So my 5 minus 10 for my base m, my 4 minus 1 for my base n. Using subtraction, I get m to the 5th. Subtraction, n to the 3rd. Why am I able to keep the n to the 3rd right where it's at? Because remember, these guys are in the numerator as it stands right now. I could put this all over 1, right? I could put this all over 1, this quantity. I can put this quantity all over 1. So, and if this was a fraction, I'm keeping n to the 3rd in my numerator, right? Because he's positive. He's good to go. I'm not going to touch that guy. The only problem I see is this m to the negative 5th. I do not like negative exponents. So I bring that guy down to the denominator. Remember, all you're doing is flipping between numerator to denominator. So let's do one more crazy looking one, and then we'll be done with example 1. So a little FYI, if you see me looking around, I'm not freaking out or anything. I'm just making sure I have the right timing for each example and I have the right buttons clicked on ready to go, okay? So next problem, I'm looking at 3, is that to the 5th? Sure. Being multiplied by 2, being multiplied by 4 to the 3rd, all over 3 to the 4th, being multiplied by 2 squared, being multiplied by 4 to the 6th. Okay. So before I even begin the problem, I want to look to make sure I have the same bases lined up. 3 to 3, 2 to 2, 4 to 4. That's good to go. Do any of these exponents need a 1? This guy right here, before we even begin the problem. So before I like to dive into each problem, I want to make sure I'm helping myself out. So I'm adding these small things that help me with the mathematics. So up top, again, I can multiply all these numbers out and then divide by the fraction, but I want to be working with this division property of exponents. So because the numerator is cleaned up and the denominator is cleaned up, what I mean by that is that it's simplified, I can use the division property of exponents, and I can break it down one at a time. So what I'm going to do is 3 to the 5th minus 4, and then I can have everything else staying the same. Math is not a race. It's not about who can get it done fastest. So right now, the only thing I'm working with is this 3 to the 5th minus 4. And that's going to give me 3 to the 1st. And then in the second problem, I'm going to work with my 2's. So it's 1 minus 2. And then what's left over is 4 cubed and 4 to the 6th. What's 1 minus 2? It's going to be negative 1. So 3 to the 1st times 2 to the negative 1, and then my last division property is going to be 3 minus 6. So 3 to the 1st being multiplied by 2 to the negative 1 being multiplied by 4 minus 2. Okay, what don't I like about these guys? These right here. I have 2 negatives. Again, we do not deal, put it down a little bit, we do not deal with negative exponents. So 3 to the 1st is going to be up top, and I'm going to bring my 2 down. 2 to the 1st being multiplied by 4 squared. And then from here, I would be doing, because I'm running out of room, we'll go over here. So I'm doing 3 all over 2, and then that's going to be 16, which is going to be 3 over 32. So over here, we see that, and that can reduce. I'm running out of time, so I'm trying to wrap this up fairly quickly. So that is going to be my final answer. Okay, so quick recap, because I have about 40 seconds to do that. I have, pull that closer. So here's the original problem. I started using the first division property of exponent with the first number I saw. So 3 to 5 minus 4, which got me 3 to the 1st. Then I'm going to do 1 minus 2, which got me 2 to the negative 1. And then last but not least, 3 to the negative 6. And then I was left with this. I look at my negatives because those are the only ones that I need to switch. -1, -2, I moved those down to the denominator, and then I simplified it to this.